For the first time, astronomers have found a stripped, throbbing core of a huge star. They detail the unusual item and the work they undertook to confirm its composition in their research that was published in the journal Nature Astronomy. Stellar cores are the innermost regions of stars, as their name implies. Such cores are typically protected by what space scientists refer to as their opaque envelope. According to theory, if circumstances exist that cause the envelope to be removed, such cores may manifest themselves without it. But this had never been noticed before. The scientists noted that the discovery of Gamma Columbae, a star thought to be average and typical, was wholly unexpected. When they were studying a cluster of stars, they discovered that the evidence pointed to one of them as being out of the ordinary. Because of this, they decided to examine the star's light spectrum in greater detail, which led them to find signs of a lost envelope. The researchers highlight that for such an item to exist, something had to have peeled the envelope from a typical star, leaving its core left. The thing would have been substantially smaller as a result. Before losing its envelope, they calculate that star to have had a mass of around 12 times that of the Sun. It is now just 5 times as massive as the Sun. They point out that such an item would not exist as a stripped core for very long, possibly just 10,000 years or so, a true blink of an eye in astronomical terms, and that finding the unique object was truly a matter of chance. They also point out that earlier studies indicate that Gamma Columbae was probably an ordinary big star before it was stripped, having probably ran out of hydrogen. That might have caused its envelope to enlarge and possibly draw on a companion star, which might have caused the envelope to be ejected. They point out that the object is currently burning helium, but eventually it will start fusing heavier elements up until it bursts into a stripped core supernova, at which time it will turn into a neutron star.